Okay, we're going to pick up where we left off at with the part 8. We ended on part 8, and we dealt with the hip, and now we're dealing with the valley. Now, this right here is a little bit more complicated, okay? And I'm going to give you some theory behind all of this, okay? Now, let's look at this. Here we have our outside walls, dotted lines representing the building line on an inside corner. This is the inside corner of where the two subfascias meet. This is a subfascia, this is a subfascia. They both meet right here, all right? So when you have these two subfascias right here, with this wall here, and you still have the same type of hip that you had for the 712, 1212, the same slope. But this time, because it's an inside wall, it's a valley. The rafters are going to be coming in from here on up for the 7-7 side. For the 12-12 side, they're going to be coming down this way. Why? Because this is a valley. This represents the outside wall. So the plate where the bird's mouth is going to be sitting is going to be on this wall here and on this wall here. So the 12-12s are going to be going this way, and the bevel is going to be at the bottom of the 12-12, not the top of the 12-12. That's for if you're doing valleys. That's for if you're doing hips. But if you're doing valleys, it's reverse. It's going to be at the bottom of the rafters. And the same thing with the 7-12 side. The 7-12 side, the rafters are going to run this way. They're going to have the same bevel on them that they had before, 59 degrees or 60 degrees. And it's going to be on the bottom of the 7-12. The bevel is going to be on the bottom of the 7-12 rafters. Okay? Now that we got that out the way. The distance from here to here, which is the building line to the outside of the subfascia, is 16 inches. We have it marked here. We have it marked here. Inside, of course, is 14 and a half. Pay very close attention to this. What we do, since we know what this measurement is from here to here. Now, don't look at this dark line. We're focusing on the dotted line, okay, which is the inside corner. I know it might be a little confusing with all these lines, but we're looking at the inside corner as if it is the building line for an inside corner, all right? So from the outside, from here to here, it's going to be 6.671 inches. But if you take 6.71 inches and subtract it from 16 inches, you're going to get 9.329. That's how I got this. So now I know from the center of my valley all the way to the outside of my sheeting, I know exactly where this hip is supposed to, this valley is supposed to be. And it's going to sit on the wall with the 7-12 rafters. You see? Because this is the 7-12. This is the 7-12 wall plate. This is the 12-12 wall plate for a valley. Okay, it's just reverse for a valley. Now what we do now is this. We have our 9.239. We know how we got that by subtracting 6.671 from 16 inches, and that gave us this. Now what we do is we divide 16, which is the building line to the outside of the subfascia. We divide it by 9.329. Divided by 9.329 equals. Okay? That's really good. That's really good because look at this. 1.714. I got 1.175. So this is good. That means we're being perfect. Now what we do with this number here is we press the inverted function for the tangent. And we get 59.75. We got 59.76. Good enough. That's perfect. 60 degrees, basically. Then what we do is we cosine and divide the degree by inch into inch segments. Okay? And we get 9.85. Now, I want to show you this. We take this measurement and we multiply it by 7.829. Why 7.829? Because 7.829 is 1 inch and a half shorter than 9.329, which will bring you to the inside of the subfascia, not the outside, because the valley is not going to go all the way to the outside of the subfascia. It's going to stop right to the inside of the subfascia. All right. So I'm going to put a little dot here for where that stops. Okay. Then what we do is we take this number and multiply it by the 7.829 equals. Okay. Okay, let's go. Okay, times 7.829 equals. Okay, let's try that one more time. Let's just do it all over. 16 divided by 9.329 equals. Okay, that's good. Second tangent, that's good. Cost, we got that. Okay, yeah, that's what I'm looking for. 0.895, okay. Then we take this number and multiply it by 7.829 equals. That's right, 15. So this right here, I did it earlier and I messed it up. So we're going to erase this here. And we're going to put 15.54. And that's inches. Now, this right here is the run of the tail for the valley, which is from here to here. From that point to the inside of the subfascia. It's exactly 15.54, which is basically 15 and a half. Okay? Now what we do is take this number and we divide it by 16.97 equals. Okay? And that gives us 0.915. Now what we do is take this number and multiply it by 19 times 19 to get the tail length of the valley equals 1740. So this right here is 1740. Basically 17 3/8 inches. All right. So we have solved for the tail. All right. And remember, we're measuring, taking our measurements. When we measure off for this hip, when we measure off for this valley and or hips, we always measure to the center, from the center of the hip. Okay. No matter if it's a micro lamb, if it's a LVL, whatever it is, you measure from the center. Now, I want to show you something else. We're going to take this right here and we're going to check this. We're going to check this. Okay? And this is what I'm going to do. We're going to copy these measurements here. We got 15.54, 15.54 inches. All right. Now, from here to here is the inside of the subfascia. This line right here represents the inside of subfascia. Okay, I want to put inside of subfascia, inside of sub. Okay, IS, that's what this line represents. This line represents outside of subfascia, OS. Okay, put an arrow there, put an arrow there. Now, from here, this point to this point represents the same as this point to this point and this point to this point. All right? So, what we're going to do is check this. We're going to check this. So, we know that from this point to this point, we know that that's 16 inches. From this point to this point is 16 inches. So let's plug that in. We know this is 16 inches. And we know, and we'll put a dot here too. We know from, okay, let's do this. We know from here to here is 9.329. You see that? From here to here is 9.329. I'm just doing a blow up version of this. Okay. We'll make a big bracket here. Okay, we know that's 9.329, and that's inches. All right. Now, we know that from here to the inside of the subfascia, because this line here, it represents subfascia. Okay, from here to here, it represents subfascia. We know that that's 1.5 inches. And the measurement from here to here, inside subfascia, we know that that is 7.829. So we're going to plug that in. 7.829 inches. Okay, we know that's 7.829. Now, what we want to do is see how tight our measurements are and how correct this is with our overhang. Now, I don't do this on a job site. I do not do this. I'm doing this for illustration purposes so you can get the theory and see how this works with the calculator and practice it yourself. Okay, and this also, whenever you can learn a way to check your work, you want to, that's awesome, because you got other ways of determining things besides just one pet way. And I'm not saying that everything that you figure out on the job site, you do it with a calculator. Some things it's not practical to do with a calculator. Okay, there's a lot of things on the job site that's just not practical to do with a calculator, and it don't even make sense, and it's time consuming, you see. But if you're doing some really, really custom homes, you're going to want to know these things. You're going to want to know some of these techniques and pull them out of your toolbox whenever you need them to be able to solve a problem, to find a problem, whatever, or to engineer something or design something. So watch this. We're going to show you something here. 9. Let's see. Okay, we got 9.329 already stored into the computer. All right, so this is what we can do. 16, we're gonna go 16 divided by recall 2, which is 9.329, equals, okay, 1.175. That looks beautiful. Now, we know that our, let me see. let me use some of these the proper terminology for this. I'm pulling out my roof framers roof framing book by Marshall Gross. All right, and I just want to use the right terminology, because I get secants and tangents and all that kind of stuff mixed up. So what I'm going to do is look in here and just see what it's called. Okay, rise divided by run is a tangent. That's what a tangent is. A rise, the rise divided by the run is a tangent. Okay, and then the rafter length divided by the run is a secant. You see that? The rafter run divide. So we know what a secant is. The secant is the rafter length, or the hypotenuse, divided by the run, or the side adjacent. No, side opposite. That would be side opposite. So I don't mean to confuse y'all with the terminology, but this is opposite of the rafter of the hypotenuse. So that would be side opposite. This would be side adjacent. Okay. But anyway, so we know what a secant is. A secant is the hypotenuse divided by the run. A tangent is the rise divided by the run. The rise divided by the run. So you got the rise divided by the run and the hypotenuse, or the rafter length, divided by the run. So that's the difference between a tangent and a secant. So looking at this as the rise and looking at this as the run, okay, what we want to do is this. And when we divided this rise by this run, or the run by the rise, you get a secant. Okay, and that is 1.175. Now what we want to do is divide let's see here. Okay, I think I labeled something wrong here. Yeah, this does not belong here. 15.54 belongs here. And it goes from here to here. That's 15.44. 15.54. I wrote that in the wrong place. Okay. And of course, this line right here represents the center of the valley. And it's 15.54 inches. All right. This doesn't belong here. Now, what we're going to do, there's a way that you could check this, and I'm going to show you that. What you can do is we're going to do the 9. We're going to recall that the 9.3. Okay, and we're going to divide it by 16. But then we're going to multiply it by 7.829. Okay, I did something wrong. Okay. Divided by 16 equals times 7 point. Oh, I guess I should be. I think I'm dividing this by this, but I should be dividing this by this. Because what we're doing here is we're going to see what the measurement of this is in 1.5 inches. We want to see how long this is going to be. That's what we want to do. So to achieve that, we have to put the 16 in first. 16 divided by, recall 3, which is 9.329, equals, which is good, times, that's our tangent. And if I recall, the tangent is the rise divided by the run. Yeah, that's what it is. The rise divided by the run is the tangent. And so we take the tangent and multiply that by 7.829 equals. Oh boy. Okay, let's do this. Recall 3. I already got the tangent stored in the computer. Times 7.829 equals. Okay, so this lets me know that this line is 13.427 inches. All right. So if you deduct 1.5 inches from the starting point, this is the starting point for everything, for at least for the valley. Okay. And you come in 1.5 inches, that means the hip is only going to be, the valley is going to be 13.2. This is a 2. 13.27 inches. But if you go out 16 inches, it's going to be, no, yeah. But if you go out 9.329 inches from here to here, it's going to be 16 inches. So now I know to the center of my valley exactly what the length is for the tail to the bird's mouth. All right. Now, the way you can check this is you take this measurement here and you divide it by 7.829. 7.829 equals, you see that? 1.175. That looks very familiar, doesn't it? Yeah, that looks very familiar. You know why? Because that's the measurement we got. We've been having the whole time. Okay, I got 1.714, and this is 1.745, which is good. Perfect. Okay, and then you take that. So that lets us know. Now, you take this and do this, the inverted tangent. You invert the tangent so you can get degrees. And look at that. 59.75. Watch this. 59.76. That's within 1/100th of an inch. You see? So that lets us know that the tail length for this valley is indeed 15.54. Now, I went through a whole roundabout way of showing you that, and I took a lot more time, and this is something that you just can't learn on a job site. I'm going to tell you, you can't learn this on a job site. Nobody teaches this on a job site. You have to learn this in a classroom. You have to learn this in a setting like I'm doing right now. You see? Now, a lot of these techniques that I'm showing you are not practical to do on a job site, because you're there to make money and you're there to do it as fast as possible. And so you have to make the determination on where to cut, I won't say cut corners, but to where to implement these things, these techniques, and where not to implement these things, depending on the size of the job, how much money is in the job, how many guys you have on the job, material, it's the size of the material. It's a whole lot of different factors, you see. So yeah, I showed you how I got the for the valley, for the hip, and from the hip to the valley, which is from here to here. This is the bird's mouth for the valley. This is the bird's mouth for the hip. Okay. So I guess that's all for about right now. There's a whole lot of other things I could show you. Many other things I could show you. But I'm going to stop right there for now so I can review this material and see what else I need. Oh, I know what I need to show you next. I need to show you how to cut plywood angle is what I need to show you. Figure out, and the jacks. So yeah, that's going to be in part 10. So this is Lewis Thomas with Master Carpenter Series, your Master Carpenter. Any little detail about roof cutting, angles, pitches, all kind of little stuff. These are tried and true methods that will help you. All students should start learning these type of things. These are invaluable. They not only help you out in construction, they help you out with your logic of math, algebra, geometry. And I'm talking about real world geometry, real world trigonometry, real world algebra. And so I'm signing out, and you all have a nice day. Be sure to subscribe, leave comments, share this video, share it with your instructors, share it with a builder that's looking for a construction pro. Let me know, and we can see what we can do. All right, I'm out of here.